Alright guys, a couple of our last problem here in related rates. First, let's do the example 4. So water is draining from a cylindrical tank at 3 liters per second. How fast is the surface dropping? So remember, start off by analyzing the problem and write down what you know, okay? So we know that the water is draining. Water draining means you're losing volume. So you would say the change in volume with respect to the change in time is equal to minus 3 liters per minute or second in this case. And what we also want, so we want to know how fast is the surface dropping. So just imagine this, all right? You got a cylinder and the cylinder is losing water, and we want to know how fast is the surface dropping. So the surface dropping means that we are losing the height. So they're looking for the change in height with respect to the change in time. So we start off next by writing down how these two are related. So we begin with the formula for volume of a cylinder. So volume is equal to pi r squared, which is the area of the base, times the height. And remember, these are functions of time because as time progresses, we're losing volume and we're losing height. So make sure you make a note of that. That's a function of time. The radius is not a function of time because the radius will always remain the same. So it's actually a constant, but the height will also change. So the height's a function of time. Alright, so we write down what those are related. Now we go ahead and we differentiate both sides implicitly. So the derivative of the volume is dV over dt. The derivative of this is going to be pi r squared times 8 times dH over dt. We're interested in the change in the height. So you solve for dH dt. So dH dt, that equals to the change in the volume with respect to the change in time. Divide that by pi r squared. Now we replace what the change in the volume is. The change in the volume is negative 3 liters. And then pi r squared. And because we don't know what r is, this is the best we can do for this problem. So the change in the height, the rate at which the height is changing, is negative 3 liters per second over pi r squared. Alright, very good. Let's go ahead and take a look at our last problem. This one is going to be kind of challenging. Alright, so let's go ahead and draw a scenario and then we'll list our information here. Let me find myself a different pen and I will proceed. Alright, so here we go. An airplane is flying at 450 kilometers per hour at a constant altitude of 5 kilometers. So let that point be our airplane and let this point be our ground. Then since we know that the altitude is 5 kilometers, that would mean that the airplane distance to the ground is 5 kilometers. And it's approaching a camera mounted on the ground. So maybe the camera is mounted over here, and the plane is flying this way, so it's approaching the camera. Let theta be the angle of elevation. So here's the airplane. Remember, here is the camera. So theta, here's the ground. So theta is the angle of elevation to the plane. Alright? This is the plane. When theta equals to pi over 3, how fast does the camera have to rotate in order to keep the plane in the view? So as the plane moves forward, the camera has to turn so that it keeps focus on the camera. So here's what we know. We know from reading the information that the plane is moving at 450 kilometers per hour. So if we let x equal to the distance from the projection of the plane to the ground to the camera, then x would be the horizontal distance. Alright? And if that's the horizontal distance, then by given this information, we know that the change in distance with respect to the change in time is equal to 450 kilometers. And we also know that the altitude equals to 5, alright? So if we consider this as y, then y equals to 5. It is currently 5 kilometers above ground. What we want is we want to know how fast does the camera have to rotate. So how fast does the camera have to rotate involve the change in the angle. So we want to know the change in the angle with respect to the change in time at theta equals 2 pi over 3. So that's what we want. Now we want to go ahead and write a relationship between these three things. How are the rate, this rate would be related to this rate, the change in this angle. So we start off with the relationship between these three, which can be expressed using tangent. So tangent of theta equals to, remember, tangent is opposite over adjacent, all right? And again, once you write down what is relate, remember that these are changing in as a function of time. So make sure you tackle time. Theta is a function of time because the angle is going to change as time progresses. All right, x is a function of time. Once we write that as a function of time, we're going to go ahead and take the derivative of both sides. The derivative of tangent is secant square theta. But remember, we got to multiply that with the derivative of the inside, which is d theta over dt. And then the derivative of the right side. The derivative of the right side, once done correctly, you can use the quotient rule. You can think of this as x to the negative 1. But once you do this correctly, you will get negative 5 over x squared of t dx over dt. Alright, remember, secant square is 1 over cosine square, so let's write it as 1 over cosine of theta square. So it's easier for us to evaluate everything. Alright, x squared of t dx over dt. Sorry, I'm running out of room here. I'm going to improvise with some room. Where can I improvise? Sorry, let me get some paper real quick. Alright, here we go. Found some paper. So our next step is to go ahead and plug. We want to solve for d theta. So d theta dt is going to equal to, multiply both sides by cosine square. So cosine square theta, don't forget the 5. Okay, over x squared of t dx over dt. Now, we know what dx over dt is because that's given to us. See? We know what theta is. Theta is pi over 3. And we can pretty much find what x is because once you know theta equals to pi over 3, then you can use this relationship to find what x is. Alright, so let's find what x is and we'll plug it in. So inside this box, I'm going to go tangent of theta over 3 is equal to 5 over x. So tangent of theta over 3 is going to be tangent of theta over 3. Lazy right now, so I'm going to do some cheating. I'm going to go ahead and let my calculator do the work for me. Right, so tangent of theta over 3, I'm sorry, pi over 3 is going to be 1.73. 1.73 is really rad 3. Okay, so let's double check. Alright, so that's rad 3 equals to 5x, so x equals to 5 over rad 3. So we know what x is, so we're going to go ahead and we're going to plug it in there. Alright, so we're going to plug this in there, so d theta over dt would be equal to 5 over rad 3. and then negative cosine square of pi over 3 times 5 times 450 kilometers. Alright, so let's multiply those together. Pi over 3 is going to be, let's see, cosine of pi over 3 is going to be, my brain is fried right now, so I'm going to do this to make sure I don't make mistakes on this answer. Alright, so that's going to be 1/2, so we're going to look at negative 1 over 2 times 5 divided by 5 over 3 times 450. Multiply all those together, and that is the change in theta with respect to the change in time. Alright, that product is how fast the angle is changing when the plane at exactly theta over 3 of the angle. I'll see you guys the next time.